So as you can see right here, you can now, instead of factoring, you can square root both sides because you have two sides. Over here, you're just gonna factor. And there's a property in the notes and in the videos and in the book that says if you factor, if you have a factor times another factor, so a times b equal to 0. I'll show you right now. This whole idea is based on this theorem. So an a times ab equal to 0, then logically that means that one of them has to be 0 or both are 0, right? It's the only way you're going to get 0. I'm assuming that logic is clear. So that's why you're able to, once you factor something into something times something, right? We always jump to this type of stuff. That's why it happens, and that's what we're going to do. If you can factor something, then you can just solve each factor separately. Okay, that's what we're going to do right here. So this should be somewhat review, not too much. I'm pretty sure everyone here has solved the quadratic equation at some point. So let's do some of every type and see how it goes. Okay. I extended the due dates on 1/4, 1/5. I think they were a little too soon. I don't know if anybody noticed or not, but they should have been changed.
Or which one? Sorry.
1.4, 1.5, I think were due like yesterday, but I fixed that.
Okay.
I'm not sure if that was correct or not, or if anybody saw it, but applications. No, we have nothing will be due before we talk about it. That doesn't make sense, right?
You have the little thing that says talk to your teacher or ask your teacher a question. Does that actually work, or is that just a fake?
It should. I'll double check. Try it again now and see if it goes through. Although
I sent you 4 messages doing these assignments. So
really?
mm-hmm.
Okay. Yeah, I'll check. If you still have them, you can also just screenshot them and throw them in Remind, and I can give you an idea as well. Like give you some feedback. That might be faster, but yeah, go ahead and try it again and see if it goes through for in the future. It might have been buried in emails, because the first 2 weeks are crazy. Or maybe it didn't go through, but yeah, let's try it one more time and see.
I have a question.
What's up, man?
Yeah, so in the very first homework assignment, you were able to change the submitting to each one of the problems immediately. But the rest of them, I had to submit the entire form. Can you change that or no?
Yeah, I realized. So I've learned one workaround. So the answer is yes. I just haven't figured out how to change it for the entire class. So far, I've figured out how to change it problem per problem. So I need to call the people, the publisher basically, and see if they can help me out, because that's annoying. But thanks for reminding me. I had forgotten about that. Let me make a note of it right now.
Yeah, the submitting of each individual problem really helped out, but when I had to go through and do the entire thing and then submit it, and then it would redo every problem. It looked like they were all wrong. That was difficult. Thank you.
No, I hear you. I agree with you. It should be fixed. I'll do that as soon as I'll email them today after class and see what they say. In the meantime, I'll try to do it myself, and at least for 1.4, 1.5. And then they
One
can.
thing I did figure out is if I did miss one, all I had to go back and redo it, just that problem. And it would still only count that question as correct or whatever. So you don't have to
okay.
redo the whole page, just the one problem that you missed.
Oh, okay. So it's not completely screwed up. Just I
Yeah.
see. Okay, thanks for letting me know. Yeah, my other classes aren't like that. I don't know why this one is. Something's off. All right, well, let's get to it. Solve the quadratic equation by factoring. So whenever you're solving a quadratic, it's always going to be factoring almost every single time. So this is example 4. Okay, so I'm going to send you a list, but there's a list of priority on how to factor. The first thing you do is count the number of terms. And if you have 2 terms, then that kind of limits you to what type of techniques to use. But the first thing you do is check for a GCF, because sometimes that's all you need to do. Right, so here we have, what do these two have in common?
4x.
Yeah, it's going to be 4x on each of them. So if you factor that, you're going to get 2x plus 1. Now, as I said before, and the zero factor property says if you have something times something equal to 0, 2 things with variables, set it to 0. You don't really need the parentheses, but same thing. Okay, so at this point, just solve for x. Divide by 4 on both sides, right? X is 0. Subtract by 1. So move the way I like to think about it is just I'm moving the 1 over to the other side, and if you move it, it switches signs, right? Or technically what's happening is -1, -1. Final step, divide by 2. So x is -1 over 2. So we have our two answers. They should both work. So on the first example here, right, the first type of problem you're going to run into is GCF factoring. And since we didn't do anything fancy, you don't have to check your solution. You only have to check if you square both sides. Any questions on the first one?
But what do you mean by square both sides? Like,
If you square if you square everything on the left side of the equation and the right side of the equation, then you introduce erroneous solutions. So sometimes you have to square. It might not come up here. Let me check if it does.
so the erroneous solution is this when you square both sides.
Right. I don't think that comes up here. But if you had like an equation with square roots in it, and you wanted to get rid of the square root, you would have to square the equation. But when you finish solving, you have to check if one of those solutions are false. But I don't think that's a thing in this section. Okay. Yeah, not here. I was double checking. Any question number 1? Okay. So they're all going to just be solved. I'm not going to write everything. It's implied that if you're solving a quadratic, it's going to be via factoring. So this is number 6. That's a 14. Okay, so negative x squared minus, or negative x squared plus 9x equals 14. So we need to set this to 0. Whenever you have a quadratic, you should try to set it to 0. So I'm going to subtract the 14 over, just move it to the left. If I cross an equal sign, then I got to switch my sign here. Okay. Now, when you're going to factor, you shouldn't have a negative on the x squared, the quadratic part, if you can help it. So just multiply everything by -1 or divide by -1 to switch your signs. So you can technically switch whenever you want. Just make sure you do it to both sides. And since there's a 0 here, it doesn't matter, does it? -0 is 0. So this minus will swap. These will swap. Okay, so now the trial and error method, as we talked about last time. The first term is going to be x, because it's the only way to get x squared, right? X times x is x squared. We look at the factors of 14. So if you're not good at factoring, you can create a little tree over here. So so to get 14, we get 2 times 7. -2 times -7, right? Those are two ways to get 14. 1, 14, -14, right? There we go. -1, -14. Now over here, so these are the factors right here. Over here, you sum them up. So if you add 2 and 9, I know right here, these are being multiplied. These are factors. If you add them up, 2 plus 7, add these up, that's a negative. Add these up. And then you choose the one that gives you the center term, right? That was a technique we did way back when. So -9 is this one. So this is the correct option. It'd be -2, -7. Doesn't matter what order, it is the same thing. So at this point, set them to 0 and you solve. Any questions on this trial and error method? Okay. So I recommend to use this method whenever there's only a 1 on the quadratic part. So if the coefficient of your quadratic is a 1 or a -1, see how these two right here are similar, then just do it this way. Just look at but first put it into this form, right? This one you had to do one extra step or two. And then you do the factoring, okay? 7, 8. 7 and 8 are going to be square rooting both sides. It's another technique. It tells you right here. Square roots, right? You want to move on to square root type. I'm going to do the hard one. Number 8 looks weird. But so far you guys are good, right? Not too bad.
Yeah.
Okay.
Yes.
I'm only going to do 2 sections today, and then I'll leave time for some homework questions or whatever. All right. So whenever you see a square on the left and the right, that should be a hint that you should try square rooting. Especially if you see this right here, it's already squared. You should give that a shot. Doesn't matter what's over here. Just square root this, because if you don't, you're gonna have to multiply this out and then move this over, and it becomes more difficult. So square root both sides was the hint that they told us. But just remember, whenever you square root both sides, you have to tack on a plus or minus. This comes from a definition. If you're wondering why, it's a definition.
I have a question.
Mm-hmm.
So the plus or minus, that feature, how do you get that on the exam for the homework? Don't.
Well, I mean, you could get it on the homework. Sorry, you're cutting off. I'm assuming that's what you said. But that's not how you're going to solve it. You're going to create two different equations.
Yeah, I tried to do it. There was a little one of the functions you were able to put the plus and minus, but on the browser it doesn't actually read it. So you have to do it separately with a comma.
Yeah, I had to do it separately too. I was just asking. I thought maybe plus or minus. Thank you.
No, yeah, you
Yeah, I
should
think
do
that's
it.
the only way.
You should do it separately anyway, because here it's not finished, right? So you have to move this over, and it's gonna be different. Sometimes it is just like, I don't know, the answer is 7 and minus 7, then it would be nice to do this, but it's not necessary.
I have a question.
Yeah, what's up?
So isn't it plus and minus because since it's quadratic, you're supposed to have like two solutions?
Yeah, it comes from that definition. Yeah, you're right.
Okay.
So just move the 4 over here, becomes plus, move the negative over here, becomes plus. This is a minus 7, that's a positive 7, so this gives us 11. This gives us negative 3. So in your homework, I'm pretty sure they want you to type 11 comma negative 3, right? Something like that. I forget how they,
Yes.
let me see. Yeah, right here. Here they actually had 2 spots for it. Sometimes you get you go with a square root plus a number, so they have an approximation. So if you had to approximate, you would put in the exact solution here, and then you would punch it in a calculator and get a decimal and put that here. That's what they're asking for. Any questions on 3? Example 3.
No.
All right. Completing the square is another technique. Usually comes up with circles, but for some reason it didn't come up for us, but whatever. It's going to come out now. 9 and 10, basically, you complete the square and you force it into a problem where you can use the square root. The square root technique when we do both sides, just like this last example. So we're going to complete the square and then apply the square root property. Let's go ahead and do, I don't know. This one has uglier answers, but that's fine. Yeah, we'll do 10, I guess. I'll leave 9 and 11 to you. That's the same type of question. Okay. You guys are good on the first 3, right?
Yes.
Yeah.
Okay.
Yes.
And just stop me anytime. It's no big deal. All right. So let me refresh your memory. If you don't remember how to complete the square, this is the procedure. What you want to do Let's see what's a good first step. First is move this constant over to the right. And if I move it to the right, it becomes a -2, right? On the next, and then you basically leave like a little space here because I need to add a special number to complete the square. So that special number to complete the square, add b/2 squared to both sides. Where ax plus bx plus c is your quadratic equation, right? That's a general form, right? Yeah, so you're gonna take the half of 4, but then you have to square it. So our special number is gonna be half of 4, right? Which is 2, and then you're gonna square that, which is 4 again in this case. So this special number here is going to go here.
Is this completing the squares or?
Yep. Completing the square. So this is the idea. Half of b squared. It's always going to be half of b. But just make sure it's in this form. Okay. There's no numbers on the x squared. The x squared is positive. Then you do half. So it has to be exactly of this form. And that's the key. See how the a is positive? The b is whatever, it doesn't matter what the b is. Okay, so once you've done, yes, go ahead.
No, I didn't mean to interrupt. Sorry.
No, you're good.
When you're adding the 4 to the other side, is it the opposite of what it is, or am I thinking of something else? So is it going to be -4 when you're adding it, or no?
You're thinking of completing the square on the same side. Like if I didn't have an equation, I'd have to do +4 -4. But since I have two sides, I can just add 4 to both sides and not worry about it.
Okay, I'm thinking of something else. Sorry.
Yeah. No worries. So at this point, because it is completed square, it's going to factor like this. A plus b, where b is 4. 4, not the heck. No, it is 2. It's the half of b here, because if I FOIL this out, 2 times that times this. Yeah. Okay, sorry. I was doubting it for a second. So whatever this is going to go here. And if you were to factor with trial and error or use the formulas from last time, you'll end up here anyway. But it's always going to be x plus half of b. Any questions on the factorization?
No.
Okay. All right, at this point, do what we did in the last example. Do the same thing. Square root both sides, right? Subtract the 2 over and we're done. So we technically have two solutions, right? We got x equal to -2 plus √2, and -2 minus √2. So you'll just type them in with a comma. Now that's what they did here. Number 9 will be the same thing. Just move that 4 over. The only thing is your b is 3, so it'll be a fraction. So half of 3 is 3/2. Square that, add it to both sides. Number 11, you're gonna have to factor the 8 out first, so it doesn't mess you up, and then complete the square. So slightly harder, but same kind of stuff. Number 12, you're just graphing. You can use your calculator or Desmos. I don't care how you do it. There's a lot of online graphers. Just select the right one. Quadratic formula. It's been a while since we've done that one. Let's see. Numbers 13, 14, 15, 16, 17 are all the same type of question. So they really want you to practice using the formula. So let's do one. You guys cool on this page?
Yeah.
Okay. That's number 4, right? 5. Use a quadratic formula. Let's go ahead and do 16, I guess, has a I in it. Okay. So the formula comes from solving this guy. You can actually derive the formula. It's kind of cool. But we won't do that here today. So if you were to solve for this in general, solve for x, you end up with this guy. What is it? Let me double check out of paranoia. Did I miss any signs? Nope. Negative b is built in. Plus or minus is in the right place. B squared minus 4ac. Yeah, everything's good. All right. So all these letters, all these variables are coming from here, this a and b and c. So for their example, you can technically use it on this one. You can technically use this formula on any quadratic, and it will always work. But this method is the most tedious. So only use it when no other technique works. It's kind of like killing mosquitoes with a shotgun, right? It's not necessary, but I guess it works. Okay, so here I don't see another way, but we're gonna go ahead and do it here. Oops, that's the wrong one. Shoot. I wanted to do the one with complex numbers. All right. So what I like to do is write down all the ABC information. The A is 1, the B is 4, the C is 5, right? A, B, C. So X is equal to negative B. So negative 4 plus or minus the square root of B squared minus 4 times A times C over 2 times A. So all these numbers came from here. Right? You guys remember doing this?
Yes.
So at this
I think
point,
that's
Mhm.
the supposed to be the most effective formula, I guess.
yeah. So it's the one that always works, right? It's a guarantee, I guess, but it's not the easiest one. So squaring this would be 16. 4 times 1 times 5 will be a negative 20. That's when the issue comes from. So make sure you watch your order of operations, right? You always go left to right. You do exponents and multiplication, division, all that stuff in priority order. So this will be negative 4, right? Yeah, PEMDAS, exactly. You need to know your PEMDAS to not mess this up. Okay, so at this point, we get negative 4 plus or minus. Square root of negative 4 is 2, but you have to deal with the negative, which gives us our complex number, right? The imaginary component, 2i. Now, technically, you can divide 2 into both because this is a fraction, right? There's a 2 at the bottom. So divide both by 2 and you get negative 2 plus or minus 1i, or just I if you want. I don't like that I. Any questions on any of these steps here?
Yeah, this one.
Imaginary.
But I had a
So in the
question.
homework, in the homework, we're gonna put 2 minus I and then 2 plus I.
Yeah, so you're gonna
that-
have to write it like this, right? Exactly.
That was my question.
Okay, good. Yeah, don't do the plus or minus, right? They'll tell you in the question, separate your answers with a comma. So these are 2 solutions.
Okay, thank you.
Thank you.
Yeah, let me show you how they write it right here. Same.
Imaginary numbers used in real life or no?
Yeah, they are. They come up in engineering actually. Or Euler's equation is a big deal using imaginary numbers. Okay. Let me look at these word problems. I don't know if I want to keep them all. Just realize some look annoying. One second. Let me try to find the menu here. Okay, let's I'll do the box or this question right here. Number 18. I deleted 2 of them, so you should only have 3 word problems. Trying to shorten it up for you. Let's see. A floor of a 1-story building is 14 feet longer than its width. The building has 1395 square feet. It's nice enough they gave us the picture. Cool. Usually you don't get anything, but this will make it super easy. So all you have to do is this here. Let me draw the picture on the paper. That way we can scan this. Okay, they gave us this rectangular floor plan. They say one side is the width and the other side, they say the length is technically 14 more than the width. So they change it to be this. So we should know that the area of a rectangular surface like this should be length times width, right? They told us that the area was 1395 feet squared. So part A is what is the equation for the area?
I guess we substitute.
Yeah, pretty much. They already substitute for us if you notice, right? So it's all here. Length times width is going to be W times W plus 14, which will give us W squared plus 14W, right? Which is equal to the number they gave us, 1395. So the answer they want is this. Let me write it again, just as I looked a little messy. Part B says, find the length and the width of the floor. All right. So all we really have to do is solve this equation, right? You solve for W. If you find W, then you know what the width is, and we know that the length, right? Technically, W is equal to width. Length is equal to 14 more than the width, right?
What does foot square mean?
What's up?
What does foot square mean?
Foot square means a 2-dimensional area. So all these little squares that fit inside here. So the space in here, 2-dimensional space, is feet squared. Whereas in 1 dimension, right? If they would have said this is 14 feet long or whatever, we don't know what it is yet, but that'd be 1-dimensional space. 1-dimensional space. But together, when you multiply, then you get the space of the area, which is 2 dimensions. If you find volume, that's going to be 3-dimensional space. That's what why we always insist you put 2, 3, because we need to know what kind of units are we talking about. All right, well, let's go ahead and solve this. By looking at this, what technique would you use right away?
We can, I guess we can pass it to the other side, subtract to both sides.
Yeah, we should start doing that, right? Set it to 0. Oops. We should all understand this will be in feet, right? Okay. So we technically could do quadratic equation. Technically. But is there any factors of 1395 that would work? So at this point, it's up to you what you want to do. Like when you're solving this on your own, you can decide, oh, I'm just going to do quadratic equation because this number is too big. Or you can try dividing and see if there's some factors that add up to 14. Doesn't matter to me. Let's see. If I were to use so what I would do, just because I'm just save time, I would say, you know what are all the factors of 1495? And since 1395 is negative, right? That means that I should have a plus and a minus factor. So choose 2, right? 31 times 45 gives me 1395. If I subtract them, this is 14 more, right? So you can use your calculator and just try dividing and find factors. But if you don't want to do that, you could do quadratic what's it called? Quadratic formula. Either way, I don't care how you do it.
So what did you do 13 times?
Yeah, let's grab my calculator so you can see. All right, so 1395 divided by 31 is 45, right? So what I'm going to use, the big one needs to be positive. Small one needs to be negative to add up to 14. Then you would solve this like we did before. But figuring these out is not easy. You'd have to either do the little t, make it a list, and it might be annoying. So if you think the number is too big, feel free to do quadratic formula. Okay, it's all good. It's all good.
So this is like the AC method, more or less.
Yeah, it's like trial and error, which is similar to AC. But at this point, once you've solved it, you're going to choose positive because there is no negative distance, right? It doesn't make sense. So the width is 31. 14 more than the width is the length, so that would be 45 feet. Feet, one dimension, right? Feet. Okay. Any questions on this problem? So the answer was width 31, length for part B 45. That's what I wrote up top.
So normally when you would have a large number like 1395, is it more common to use the quadratic formula, or is it just something, is it just what you prefer?
Yeah, I mean, it's really what you prefer. I mean, sometimes there's hints that you should use quadratic. Like if the numbers are really weird or they're decimals or fractions, stuff like that is a big clue. But I saw that this had a lot of factors, so like, you know what, it's a good chance it's going to work out nicely. But if I couldn't figure it out, so if I would have, if I would have done this like blind, right, it would have been like, you know what, I don't know what the hell goes in the 1395. I would have just kept going through it like, all right, does 3 go in there? Does 5 go in there? Then I start writing down the factors or use the list from the internet that I wrote down just because I was lazy. It's just trying to figure out, okay, which one of these do I want to use? And if there's just too many and you don't want to deal with it, yeah, just switch to a different method. That's your call. Anyway, that's pretty much all of 1.4. It's just factoring, solving for x, factoring, solving for x. That's it. And you have a couple of word problems at the end. So you need to know GCF, just basic trial and error type factoring, square rooting both sides, and quadratic formula. Those are the main things you need here. And yeah, completing the square. You could complete the square on this one too. That's true. That would be another way to do this one. Okay. So that's 1.4. You guys have any questions on those ideas?
I had a question.
Mm-hmm.
So you picked the 31. I must have just missed it when I was writing it. What happened to the -45?
Oh, it's right here. So I picked 45 and positive 45 and negative 31 as the factors that multiply to 1395 and add up to 14.
Yes.
You solve for it here, right? And you get a -45 and you get a positive 31. So I can't use this because it's negative.
Yeah. So you just do away with it?
Yeah, so this is the only solution
Okay.
from that equation that I can use. This is just not
Okay. I
useful.
wanted to make sure I understood that. Thank you.
Yeah, because you shouldn't have two different widths, right? Well, you're only going to have one width. All right, so it's 7 o'clock. Let's take a just 10-minute break, I guess, and then we'll hit 1.5.
That's good.
All right, so I'm hoping you're looking at the notes and the videos, because this will make a lot more sense as we go along. But just a quick overview. The definition of the imaginary number or the complex number. So whenever you square root a -1, the -1 is defined to be I. So it's just a definition. That's all it is. Okay. Now, A and B are real numbers. Those are the real components of your complex number. So this entire thing is called a complex number. Okay. Even though only the A and B are real and only the I piece is imaginary, the entire thing is considered to be complex. Okay. So this complex number here has two real numbers, the A and the B. So all they want you to know is to identify which one's A, which one's B. The B is always attached to the imaginary part. Okay. Let's see here. Over here, they just want you to add the real add the complex numbers. Excuse me. So these parentheses, as you can see, are doing nothing because this is a plus sign, right? There's no multiplication, there's no minus. So all this really is you add the A's and you add the real numbers together and the imaginary pieces together. That's it. But notice that there's an I right here on both parts. So you'd have to multiply that out first. So the first piece is A minus 3. And then over here, we have distribute the I, you'll have a B. A B I, right? I times B and 2 times I. Oh, I misread this question. I'm sorry. They want us to solve for A and B. That makes this true. Okay, I misunderstood. So this is the A part, right? Just like up top, we said identify the A and B, right? A and B are right there. 11 and -7. Over here, we don't know what the A part is technically. We need to figure it out. It's A minus 3 is something. So we just got to solve for it. So what you do is just set this piece equal to this piece. All right, and then do the same thing for the B. So B plus 2 equals this piece. And that's all you got to do. And just solve. If I add the 3 over, that'll be A equal to 7 plus 3, right? Which is 10.
But what
Add,
happened with the I?
I mean, it's understood to be, the I's right here, but we're solving for this piece. So I'm equating this part to this part. You can leave the I if you want, but it makes no difference. Subtract the 2. And you get 5 minus 2, which is 3. Any questions on this part? See how there's not really much to do.
So by doing that, we know the equation is true.
Yeah, so now we have a number that'll make this equation true. So if you plug in the 10 in here, 10 minus 3 is 7. Plug in the 3 plus 2 is 5, so that'll be the same.
Then what happens if we get a negative or it doesn't matter?
As long as you're solving for A and B and you're setting the right parts equal to the right part, you'll be good.
Okay.
Any other questions? Okay, the next one is also pretty straightforward. These next few. If you, so you're just gonna deal with this piece and that's it. So 2 plus that negative 16. So well, the way I want you to think about it is that you factor a negative 1 out. Write that a little better. So this part becomes an I, this part becomes a 4. The square root of 16 is a 4, square root of negative 1 is an I. So that's what's happening here is this piece, and that's this piece. So using those properties we talked about, and then during the review part, you can square root factors separately. Doesn't matter which one's first, but traditionally we put the I at the end. You could have put I4, I guess, but it's just weird. It's like saying x4, you know, instead of 4x. It's not wrong, it's just weird.
So that would be the standard form.
Yeah, this is the standard form here. Okay. Alrighty, let's see here. But so far, not too bad, I hope, right? Okay. A brief note that you need to know. There's a pattern for imaginary numbers that repeat itself. So I to the first power, I squared, I cubed, I to the fourth. These would be the originals, right? Well, obviously the first power is just itself. If you square an I, you get a -1. If you cube an I, you get a negative I. If you have a fourth power, though, you end up with 2 of these, right? You agree that I squared times another I squared is the same as an I to the fourth, right? So -1 times -1 would be a +1. Do you see where these come from? Using this, I mean, as long as you know the definition of I squared equals -1, then you'll be good. Now, if you keep going, if you go to 5, it'll just repeat itself. So like I5 would be the same as the first one. I6 would be the same as the, oops, I wrote it all weird. Would be the same as the second one. So it just repeats itself. You see what I mean?
Yes.
So right here, you just deal with whatever power you got. Okay, so I squared is a -1, so this part just becomes -1. The -3i, you can't change it, so it's just -1 minus 3i. Do you see how where that comes from? So as long as you have these
Yeah.
4, you'll be okay.
Where is the I to the 3 is? Oh, that's negative I.
Yeah, -I right here. Technically, I mean, so you can use these, like if this was an I don't know, I to the 57, you can still figure it out using these ideas. You can just break these apart. But on this, in this section though, I think all you're gonna get is squares. I don't think anything else would show up, just square. So you might not even need these, but just in case you have them. So the first few questions are gonna be, all right, well, can you add them together, right? Just like we did earlier up here. Or was it? I guess we didn't. I thought we did. I don't remember. We didn't do 15, right?
No.
Yeah, so the parentheses do nothing. Just take them off. So 3 plus I is just itself, right? There's no number in front. There's no minus sign. Take off the other one too. So like terms, 5 plus 1, 3 plus 2. So 3 plus 2, I plus 5, or 1 plus 5. So that's all we're doing. We're just adding like terms. It's not anything new. This is stuff you've done before. The only difference is instead of an X or a Y or some random variable, you have the I. So the only time it changes is if there's a power on the I. That's when that's the only time you have to like, do an extra step. Okay. Otherwise it's just gonna combine like a normal thing.
Wait, how did you get the 6?
Oh, we have a single I plus 5I. So one.
Okay, so that's a 1.
Yeah, there's one I. It's like just one. It's just one of them. It's like X plus 5X, right? That's just 6X. Same deal. Over here is the same thing, except they have a minus. So take the parentheses off the first one because there's nothing in front. This has a negative. Do you remember how to deal with the negative?
Yeah, just switch it to a
Change
positive,
signs.
right?
Yeah, just distribute it, right? So minus. So you all agree that this is a positive 3 and a negative I inside the parentheses, right?
Yeah, yeah.
So the negative is
Yeah.
gonna swap them, right? So
Yeah, so -3 and then positive. What is that? I?
yeah, I. And then just combine like terms. So you distribute the minus. There we go. 4 minus 3. Negative I plus I is 0. So these are just gone. So the answer is 1. That's where they got this. Any questions on 15 or 16? Do you see that we're just combining like terms? Okay. This is the same deal, except they have you do an extra step. You first square root, deal with that negative, and then you add them. So same thing, but a little more challenging. I'll leave that to you. Over here, same thing as before, but they have more than 4 terms. Or actually, they just put the parentheses in the middle just to throw you off. But remember, if there's nothing in front of the parentheses, just take them off and don't worry about it. So 22
So
minus.
I can see like instead of the multiplying, we just like add.
Yeah, because this is not a times, right? So just take it off.
Yeah.
Don't let them mess with your head. Parentheses does not always imply times. Over here it does because they're right next to each other. But here there's a plus between them, so it's not. Let's do one of these, I guess. Let's do 20. That's 13i times 1. So you agree that that's going to be itself, right? 13i times a negative 8. So that's going to be negative for sure. 13 times 8, what is that? 10.
Yes, 104.
102.
Yeah, 104. That's close, close. Okay, so notice that they both have an I, right? So it's going to be I squared. So the first step is distributes. That's what we did over here. Do you remember what I squared is?
-1.
Yeah, so let's deal with it. So we got 13i minus 104 times a negative 1. So what is a one negative times a negative gonna happen? What's gonna happen?
Positive.
Yeah. That's where they get this number. So the answer would be just they usually you put the the constant first because that's the standard form, right? 104 plus the 13i. Okay. Any questions on 20? All right. This is a conjugate pair. Do you remember what we said about conjugates last time? A plus B, A minus B.
Yes.
What is,
Difference of squares, I guess.
yeah, this is difference of squares. So it's always going to be equal to, right, the A squared minus the B squared, right? So we said the A squared minus the B squared. So if you were to FOIL all that and you didn't notice it, you would still end up with this answer. But noticing the formula lets you skip straight to here. If you don't notice it, oh well, that's too bad. If you square this, you see how that'll cancel, right? That'll be a 5. If you square the I, you agree that that's a -1. Is there any confusion on what happened here to here? Okay. So -5 times -1.
-6.
It's
Or-
times.
I'm sorry.
It's okay.
5.
Yeah, it's gonna be positive, right?
Yeah.
So yeah, just be careful, and you shouldn't be too bad. And if you forget the formula or whatever, just multiply this out. 7 times that, 7 times this. Right, and you'll get there. I recommend the formula. Any questions on this idea? On this guy over here or this one? That makes sense?
Yeah. You make it look easy, is all.
Yeah, I just gotta. Yeah, no, it's different when you start working it, right? You start getting stumped. I just gotta keep practicing. Be all right. Just make sure you practice, even if you do know it or you remember doing this at some point. Make sure you practice, because it'll be more, or you'll mess it up on the exam if you don't. Okay. We've talked about what a conjugate is already, so I think we should skip this, but just real quick, do you remember what conjugate meant?
The opposite with the change of signs, I guess.
Yeah, pretty much. So if you have an A plus B, right, conjugate is A minus B, right? Basically. Only difference is here you have to reduce it first to simplify the root and then write the conjugate. Okay. So all they're doing here, square root of 8 would be this. Well, they didn't write the actual pair. They just wrote the one. Oh, well, they didn't say pair. So just write one of the conjugates, which is just reduce this, which we've already done before. Anyway. The last couple is dealing with complex numbers on the bottom. So 25, 26, 27 is the same deal. So you have to multiply by the conjugate pair to force a difference of squares that will get rid of your I. You're trying to force the I. Okay, so if your original is -9, then you multiply by 8 plus 9 I. Okay, so the bottom will become a conjugate. So you're going to get 5 times all that garbage. Then the bottom will be a difference of squares. It'll be the first term squared minus the second term squared. You guys cool up to here so far. Does that make sense?
I got lost in the 8 squared and
Yeah, so
on the denominator.
like where this came from?
Oh, okay. I see it. Yeah,
Oh.
never mind. I see it.
Okay. So it's part of the formula, right? Difference of squares, conjugates. 5 times 8, 5 times 9 is right there. Multiplying these two things will end up like this. If you don't see the formula, you would FOIL everything and you'd end up here anyway. So the top will be 5 times 8. Five times 9. Eight squared. 9I squared.
But Aaron, isn't the I supposed to be negative?
What's up?
Isn't it the I when it's squared, isn't it like -1?
Mm-hmm. Yeah, this is gonna be, this is squared right here. I was trying to fix this. All right, so I'm gonna go over here. So you guys up good up to here. I did some multiplication, we got to there.
Yeah.
Okay, so at this point you just you deal with this I squared, deal with the sign, combine those numbers, and you're gonna end up with a 29 down here. Or actually 29 is after you reduce, but yeah, we'll see. We'll see what happens. So this becomes 64 minus 81 times -1. So this is going to be positive, right? What is 64 plus 81? Yeah, 145, right? Okay. Because this becomes plus, right? Everyone see that this would be plus 81. Let's skip the step because this is a lot of writing already. What goes into 145 and 40 and 45?
What about 5?
Yeah, I think 5 is the best one. If you divide everything by 5, you can reduce the fraction, right? If you want to show intermediate step, you could do 2 fractions separately. So 5 goes into both, and that's when you get this answer here. 5 goes into 48 times. 5 goes into 145 29 times. 5 goes into 45 9 times. 5 goes to 145 29 times. And that's it. Any questions on what they're asking us to do, right? If you see an I on the bottom, you multiply by its conjugate. That's all you're doing. And then you just deal with the math there, the multiplying and the I squared, and that's it. It's basically a fraction. You see how on this one you do the same thing, right? 1 plus I over 1 plus I. And then you'll end up with no more I's on the bottom. You end up with something like this. Any questions on this idea?
No.
Okay. I don't want to spend too much time on this section because it's the math itself is not crazy difficult. The only thing I need you to do is just remember how to deal with the negative square roots and the i's. Anyway, I'll leave the rest to you. You guys have any homework questions that are bothering you, or any issues that you're having in general?
Issues in general.
Yeah, like,
No, I did have a homework math question. I think I might have figured it out, but just in case I didn't,
mhm.
it was for what was this? I think this was for the PowerPoint 6 homework. And
Oh,
it was
the
it was for
P6.
P6, yeah. It was for finding the distance between the points. And I kept getting a negative, or I kept getting an I, you know, the imaginary. But
Yeah,
I was gonna ask you, see if maybe you could work it out and maybe see what I was.
yeah, sure. What
Hopefully I did it. I don't know.
what were the 2 points that you had?
So the 2 points were gonna be negative 19.1.
Negative
And then
19.1.
yeah.
Mhm.
And then 16.3.
Okay.
And the other set was going to be 5.9 and 8.3.
Okay, it's nice. It helps to label them before you start. That way it'll reduce the chance of messing it up. So we know that the distance formula is the square root of x2 minus x1 squared. So whatever comes out of here will be positive because I'm squaring it, right? Anything that comes out of here will also be positive. If I add 2 positives, there's no way I'm going to get an I, right? So something weird must have happened.
Wait, say that again? What was it?
You agree whenever anything squaring any real number will give you a positive, right? Positive number.
Yes. Yeah.
So here I'm squaring a number and another number. If I add 2 positives, it should be positive inside, no matter what. Like
Okay.
logically, right? There's no way.
Yeah. Yeah.
So if you see a negative appear here, then something's wrong. You messed something up somewhere. Maybe you punched it in weird. I don't know. So that should be
I think I
like a
was
flag.
squaring. Yeah, I think I was squaring the negative 19.1.
Which one is this one?
It is P6, the section P6.
So you see where you have the that negative 19.1 parentheses. I was putting the 2 inside or right after the parentheses that closes the negative 19.1.
Oh, I see. Yeah, that's not right.
Yeah,
You have to square the entire quantity in here. So subtract and then square.
Okay. So yeah, so I did it that way. I got a different number, but I just didn't know if that was going to be right or not.
Yeah, just deal with the negative first. That way you won't mess you up. So right here, what's 5.9 plus 19.1? That'd be, is that 25? Right? 8.3 plus 16.3. What is that? 24.6. All right, at this point, we got to use a
25,
calculator.
yeah.
I mean, we probably should use a calculator for earlier, but who cares?
It's 24.6.
0.6. Okay, thank you. 25 squared plus 24.6 squared. It's gonna be 35.07. I don't know how many decimal points they asked for.
I think they were asking for 2.
2. Okay. Okay. Does that make sense? Any questions about the steps? You see where you went wrong, right?
Yeah. So I was getting confused on whether I should square that that negative 19.1 or
Yeah, I guess just the easiest
Yeah,
way to
with,
remember is subtract the difference.
okay.
I'm sorry, I said that wrong. Square the difference. Square the difference. Anyone else have any other questions from their homework or things that didn't make sense?
yes, I need a question with one of the circle problems.
Okay. Circle.
Should I share my screen or?
Yeah, sure. Let me turn that on for you. 1 second. All right, go for it.
I would like help with the 13, this one, yeah.
13. Okay, I'll leave that there for now. 1 second. Okay, so right, the standard form of the equation, endpoints are here. Okay. All right, let me write the endpoints of the diameter is going to be 4 and 2 and -12, -10. All right, I got it. Let me switch off here. So it'll help to see the 2 points graphed. You don't have
Yeah.
to, but might be helpful to visualize it a little bit.
Yeah,
4, 2 and -12, -10, right?
Yeah.
So they're saying that these 2 points are the
the
edges of,
diameter.
yes, the edge of the diameter. So if you find the distance between them, you will have the actual diameter, right?
Yeah,
So first thing you got to do is find the distance. So how far is it from here to here?
and like, am I supposed to like, um, like the one we just did, like the x1, y1, x2, y2?
Yes, exactly like that.
Okay,
So let's do it. So the distance between will equal the diameter, which is equal to x1, y1, x2, y2. So 16 squared, what's that gonna be? Then it was, oops, sorry about that.
so 56, I guess.
Did I mess that up? Let me double check here. No, it's fine. I was just being weird. What was it?
256.
Yeah, that sounds right. All right, add these together. Square root of 400. I think that's 20, right?
Yeah.
Okay, so the distance is 20. So diameter is 20.
Radius 10. Yeah.
It's 10. Oops, 20.
20,
Radius
yeah.
is 10. Radius is 10. Okay.
And I have another question.
Mm-hmm.
Yes, I'll share the screen again. Yeah.
Sure, go for it.
And for the first 14, I don't know if for the radius, am I supposed to like square both sides or
Yeah, well, the radius will always be the square root of this number here, that 49 on the right side. So this is the square radius. So r
Okay.
is square root of that. So you should put a 7 here.
Okay. And then I guess I can square I should I square the other side or
I'm sorry, one more time.
should I square the other side like the x minus 1 to the square?
No, just because remember the general form, right, is x minus h, right?
Yeah.
And then the k. So this right hand side is equal to r squared. So if you need r, you just square root this piece only.
And if I don't have R, I just yeah. So what? So like, if they like, let's say in this part, like, what would I do if they didn't give me like the 49 and they asked me to like get a point?
What do you mean? If they
Like, I don't know,
don't
like,
give you a radius, or
like instead of asking for the radius, they ask like for a point, but they just give me the center. Could I get something? Could I get a point or no?
I mean, if you have the equation, you can plug in any x value you want, and you'll find the y value. So you can find an infinite number of points around the circle.
So like, I guess I can like try to. So yeah, I tried like 2 different points, I guess. Yeah.
Yeah, they're either gonna give you the equation and ask for a center and radius, or they're gonna give you the center and radius and ask for the equation, or it will give you 2 endpoints. They might give you a point and a center and ask you to find radius. They could do that, but they're not gonna ask you to find a random point.
Right. I think that was it. Thank you.
Okay.
I have a question, sir.
Mhm.
Can I share my screen?
Yeah, go for it.
This is the one that we talked about.
Yes. Yeah. Okay. And it said perform operation and write the result in standard form. Oh, I see. I think technically standard form, the quadratic piece should be first. That's the only thing that I can see. What section was this?
3.
This P3? Let me open that up real quick. So you said P3. Let's go look at the answer, see what the heck's going on. That was number 6.
Correct. Number 5.
5. Just give me a second. It's slow. Yeah, they just standard form means
Oh,
this is first. So you're not wrong. It's just because they specified that you have to put the descending order, highest power to lowest power.
okay. Do you want me to swap that around?
Yeah, just swap what you got and it'll be right.
But it's already locked out. Homework assignment.
Yeah, that was P. What section was it again? P3, right?
Yeah.
Let's see. Yeah, I'll go ahead and open these again for you guys for a couple of days. It's not a big deal. I hope you guys out. These are the ones I closed.
Thank you. So that's the only question I had. Thank you.
All right, so I'll give you guys till Friday to get this done, right? But these were supposed to be done already.
Okay, thanks. I had asked for an extension on that. The circle, the 1.1 graphs.
Yeah, that
Or
one's extended
graphs of
too.
the equation. Okay, yeah, thank you then.
Yeah, you're good, man. Hey, I think we've gone over time. I'll see you guys next time. I gotta get to the next class. I have one right at 8 o'clock.